Hello friends, welcome back. I hope all of you are doing well. Today we are going to be studying more about differentiation, and then we are going to be studying about a very special topic in differentiation that is called the chain rule. That's from where the class 12 differentiation begins. So I've written down some formulas here which was a part of the differentiation calculus which we had done in class 11, if you remember, along with limits. We had done a small part of differentiation, the introduction of differentiation in class 11, where we came actually across all these formulas. There were some more again, so if and when needed, definitely we will be doing that. But just as a revision, of course, I wrote down some formulas. In case you don't have it, you can take out your pen and paper and start noting down. And then, of course, some of the rules were addition. So I just wrote plus and minus, addition as well as subtraction. This was, if you remember, this was the product rule, u into v, so first function into derivative of second function, or either way, since it is positive, it will not make much difference. Then of course we have the quotient rule, if you remember the quotient rule also, square of denominator, all these things. So if you have not written down, of course you can write down. So let's try to not forget this. And then of course some of the other terms were like the derivative of a constant. Derivative of a constant is 0. So I believe that you still remember all of those simple things in differentiation. So now here we are going to be studying about the chain rule. Okay, we are going to be studying about chain rule, differentiation using chain rule. But before we really go into chain rule, we first have to understand composite functions. We have already done that in class 12, that is in the first unit itself, functions. But I'll just revise that for you. For example, like composite functions. Composite functions. Now, what were actually composite functions? Okay, we may not really remember it, but the definitions and all those complicated stuffs and all, but I'm sure that you remember what it is. Let me help you with one example. Okay, let me help you with one example. So, for example, like if we just take one function, okay, let's say if we just take one function, f of x. Maybe f of x as, what shall we take? If we just take one function, f of x, okay, 2x, let's say if we just take 2x, another function, let's say g of y. So if we just assume that g of y to be like sine z, sine of y, okay, sine of y. So then usually how do we go for the composite functions? Then g of f, how do we do that? That's going to be g of the function f of x. So that will be g. What is the function of f of, what is the function f of x? The function is 2x. So now this will be, g will be another function in the function of the function f of x. So that's going to be, what is our function g? That is sine of y. But what is going to be my term here, variable here? That's going to be sine of 2x. So I believe you remember this function, isn't it? This is what we call composite functions. It's like a function inside a function. There can be many multiple functions. A function inside a function inside a function. 2-3 times it can continue. So now more or less it's something like we had this x. So from x we proceed to find out the function g of x. And then if we need f of x, then again we proceed to f of g of x. So this is the first function from x to g of x, then this is the second. So g of x, from g of x to f of x. We can again further proceed, that is f of g of x. So that's like 3 functions. So a function of a function of a function, then it can just proceed, okay, but we are not going to go that far. So this is what we call like what used to be composite functions, isn't it? Composite functions. So you must be thinking, We have started differentiation again. Why are we talking about composite functions? Because it is important. Because see here, no, the chain rule concept, formula wise, theoretically we can do, but we're not going to do that. We're going to straight use our, what do we say, just use our common sense, and then we're just going to straight away like start the differentiation. That's much easier, much time saver also. Okay, so here, like, open up your brains, just like, refresh yourself, don't think it's difficult. Okay, absolutely not, it's not difficult, very simple concept. Let's try to use our senses. No, let's not think that it's going to be quite difficult. No, don't think like that. It's very simple, but just open up. Let's see what happens. So I hope this is understood. No, composite functions from x to f, g of x to f of g of x, and then again continue. So functions of functions of functions. So now what happens is it's something like similar to, we have let's say a set. Inside that we have another set. Inside that we have another set, and maybe this is where the x variable is. Right. So this is what we call a function of a function of a function. A function of a function of a function. So that's basically called composite functions. So now basically what happens with differentiation, now we know the concept of differentiation. So if y maybe is a function x, that is y equal to x power 5, so we have already learned that how do we really differentiate dy by derivative of y with respect to x. That's simply that first formula that I gave you today, that is 5 into x power 5 minus 1, that's like 5 into x power 4. So now that was easy because it was a single function, x and x, it was a single function, so we had only just like one function with respect to x. But now problems are actually not going to be like that. We are going to be given composite functions, we are going to be given functions of functions. So now exactly here what we are going to do, I'll just talk about the concept, let's try to use that. Okay, so what we do is, like, you will be given this kind of functions which is made up of multiple functions. So what we will be doing is the concept. Okay, what we will be doing is, since the first layer definitely is not going to be with respect to x, it is going to be with respect to another function. So what we will do is we will differentiate, or we will like remove the first layer. Be with me, okay, stay with me. We will remove the first layer. After that is done, we will remove the second layer, and then we will ultimately have the last layer, that is with respect to x. That means we will go on differentiating. We will go on differentiating till we get the last function, that is, let's say, the original function from where we are supposed to start, the x-axis or the y-axis. Till that we are just going to continue with the differentiation. That's why this is called actually what? Chain. This is called chain rule. Alright, so that means if this is the direction in which the function goes, when we start our derivative, what we will do is we are going to just start in the reverse order. That is, we are going to start the derivative with respect to this g of x, that is f dash of g of x. From here again we are going to go to x, that is g dash of x. So that means from the bigger shell, so it's like, cabbage, isn't it? Cabbage, patta gobi, right? Panda gobi we call it, no? Cabbage. So it's going to be like something like peeling off the first layer of the cabbage, then again the next layer of the cabbage, and again so it's like keep on peeling off the layer of the cabbage till you really want maybe the light green part, the fresh part of the cabbage. So till you get what you really want, you are just going to be peeling it off, peeling it off, peeling it off, peeling it off. Finally, what you really want, till you get that, till the last function. So we're just going to differentiate and differentiate and differentiate and differentiate. So okay, it sounds kind of easy, but let's see exactly how it is really done. Okay, now let's just see mathematically how it is done. Okay, theoretically, we have understood exactly what to do with chain rule. Just go from one function to another function to another function. Now let's say how it is mathematically really done. So if we just assume like some functions like y, which is represented in terms of f of u, then maybe this u is another function in t, with respect to t, then another function t that is like with respect to, let's say, x. Alright, so if the question says, so that means you can see here, y is a function with respect to u. Again, u is a function with respect to t. Again, t is a function with respect to x, but what I ultimately want is, maybe the question is saying, find out the derivative of y with respect to x. So now to reach up to x, that is to find out the derivative of this y and go till x, what we have to do? We have to start from here, that is derivative of the function with respect to x. Then proceed to, but it has to be done with respect to u, isn't it? It has to be done with respect to u. Then, of course, let me just do it like this. So that's going to be like derivative of y with respect to u, because this is in the function u. Then I have to reach till x. Then of course it should be u with respect to t. Then again continue with t with respect to x. That means till I reach the function x, I will be continuing and then continue with my differentiation. So now means logically, like if you just think, you see, you just, of course we are not meant to do that, but you can say ultimately we just have dy by dx. Not mathematically, but logically if we just look at it, so it's like we have ultimately dy by dx. So that's the concept that we will be using. Okay, so you will be given like multiple functions, composite functions. So we will identifying the functions, of course, is going to be very important. So like just by the look of the question, like you should identify like, okay, how many functions are in this function, how many, this is made up of like how many multiple functions. That's going to be our main priority. And then again identifying like which is the outermost layer, second layer, third layer. Identifying those, of course, will really require a little bit of your skill, mathematical skill also, okay, because that is also important. All right, fine. So that's what we will be doing with chain rule. Now let's exactly see, maybe with some examples, how we exactly do it. So I'll give you one example that is maybe like maybe one question that is cos cube x. Okay, I'll just give you one example that is like cos cube of x. So how do we do this? Cos cube of x. So now you will see like this is like a multiple function, isn't it? This is not single function, because we have trigonometric functions, we have algebraic functions. So this, if I write appropriately, it would be better like cos x whole cube. Right, but so in that case, okay, maybe 1-2 problems theoretically we will solve how it is really done. Okay, maybe, but after that, when we start with the exercise, we're going to start directly using the direct method. So now what we will do is, you have identified your functions, no? I have. Okay, so let's see whether you and I match or not with the functions. So one function is cos x. So maybe I'll just say let the function t be cos x. Right. So in that case, then what will be my function y? Y will be t cube. And let's say we are supposed to find out dy by dx. Alright, so of course this y I can differentiate only with respect to t, isn't it? So that's going to be like 3t squared. Using this formula, x power n with respect to x, that is n into x power n minus 1. So it's already learned, these are basic things, so I'm not going to stress much on that. So t squared, but still it's not with respect to x, that means this one. That means I need with respect to x. So maybe this t I will differentiate with respect to x, the one that I substituted actually. Alright, so this is just an example. So like t with respect to x. So what is the derivative of cos x? Derivative of cos x is minus sine x. So okay, these two values I have. So ultimately now, if I want, dy by dx can be written as dy by dt into dt by derivative of t with respect to x. So t just if you just remove it, we have dy by dx. So what was the value of y with respect to t? It was 3t squared, and this value t with respect to x was minus sine x. So now we can just bring back the value of t, that is cos x. So t squared, so that's going to be 3 cos squared x. I'm just combining minus sine x. Of course, in 12 standard, at least I would expect you to at least know these basic things. Otherwise, what are you really doing in class 12 so far? Haven't studied or what? No? Anyway, that was not visible out there, so I'll just write here, that is like 3 cos square x minus, I'll bring up here, minus sine x. So this is the process that we really work upon. Okay, so I hope that was quite clear, right? Not isn't it? How was it? I think it was okay, fine. Anyway, if that was really not very helpful, let's try another one. Let's say like another question that is 2x plus 3 whole power 5. Okay, let's try this question. So now here also, could you identify how many functions are there? Like not just one function, we have two functions, you know, x power 5, you know, one function. Because see, if you compare with class 11 differentiation, that's why the formula that were given to you are like derivative of x power n into x power n minus 1, but this is not x, not here. So even if I differentiate, I will have to differentiate del y by del x. This one is going to be like derivative of this function whole power 5. The problem is with whole power 5. So this is supposed to be x, but it is not x, isn't it, as per the formula. So there's a small change. So what we will do is we will maybe just adjust, that is let t equal to 2x plus 5. So in that case my y becomes t power 5. So remember, I've used two variables, functions y and t. So now y I can only differentiate with respect to t. So that's going to be 5 into t power 5 minus 1, 4. But I need, what do I need? dy by dx. Now this substitution that we did, maybe this one also I'll differentiate with respect to x, because the function here is with respect to x. That means this was the outer shell, then the inner shell. So now we're trying to get the inner shell, that is the derivative of t with respect to x. So 2, 1. So that's going to be 2 constant 0. So now ultimately we have dy by dx will be equal to dy by dt into dt by dx. So what is dy by dt? dy by dt was 5t power 4 into dt by dx was 2. So that's like 10. T value we can substitute, that is 2x plus 5 whole power 4. So this is my derivative dy by dx. So that's basically the way we actually do. Okay? But we are not going to be writing all this in details. What we will try to do best is we will try to identify the functions and then straight away just go with the derivatives. I think you are all ready for that. Right, so now let's go back to the exercise, that is like exercise NCERT textbook, that is exercise 5.2. So now the question is, find out the derivative of the given functions with respect to x. So best thing, whenever a function is given to you, please write let y equal to sine of x square plus 5. Always write this, let y equal to. Alright, so now, actually we are all comfortable so far with only like sine theta. But of course now this is in class 12, so you also understand that this actually represents not a single function but a function of a function, isn't it? Class 12, we are all familiar with that. We can definitely at least identify that in class 12, right? So derivative, I mean, this is like a composite function. So, but the question is, which is the outermost shell? Because according to that only we are going to be removing and then ultimately finding out x. But to reach x, no, to go to x, you have to first cross the gate of trigonometric function, sine. That means sine is my first function here. Sine is waiting here. So you have to first cross this gate. Knock, knock, you know, okay, can I pass through? So only when sine says okay, but you have to first deal with me, after that only. So it's like a game. It's like a game actually. It's like a game that, okay, you have to first clear the level of sine, then only when sine allows, then only you can go to x. Okay, so that's what we are going to be doing here. So we have identified the function, so we will straight differentiate dy by dx. That is, okay, let me just start slowly and then we are going to pick up the pace slowly, just like diesel engine. So now when I start differentiating, see, the concept is this. We are going to assume, okay, we are going to assume that this is theta. So since we know that derivative of sine x is what? With respect to x is cos x. The only problem is this is not, it is supposed to be actually x, but this is not x. It is what? Rub hold, yeah. This is actually what? X square plus 5. But we will just assume, okay, we will just assume. It's okay, no problem though, let us just assume. Of course, if you want to do the lengthy stuff, one step, two steps, just like we did in the first step. the first few examples. Okay, you can do that, but when you have like multiple functions, 3, 4, 5, hota hai, okay, it happens. When you have like 3, 4, 5 functions, then who's going to write all those? So let's try to get used to this. What do we call it? Common sense way of solving differentiation using chain rule. So I'll just assume that this is x. So now if I just assume that this is x, what will be derivative of sine x? It is going to be cos x. Still assuming that this is x, but we also know it's something like we are fooling ourselves only, right? But we know that it was not x. So that value which you considered as x, you will take that out and differentiate. That is derivative of x squared plus 5, that assumed value that you took as x. So now that depends, that's why it's called chain rule. So now that depends on how many times are we going to, how many steps are we really going to differentiate. So that depends, because here we saw that we had two functions, so definitely chain rule will proceed twice. So that's why right in the first step it's very important to identify the functions, okay. So now that is going to be cos of x squared plus 5. Okay, derivative of x squared plus 5, derivative of x squared, that is 2x plus 5 is 0. So okay, we have 2x cos x squared plus 5, derivative of y with respect to x. Simple as that, okay. Alright, let's go to the second question, that is let y equal to, okay, what is the question? The cos of sine x, fine. Cos of sine x. Now here also identify how many functions do we have. Of course we have trigonometric functions, but I'm asking you like how many functions? How many trigonometric functions? We have like two trigonometric functions, that is cos, actually it should be cos theta. So it's like cos of sine x. So that means here also, but here of course we have functions of the same family before you really go to the x. That is, first you have to clear the gate of cos, then only you will clear the gate of sine x, where you will meet sine x. Okay, so you're going to meet sine x, but after crossing the gate of cos x first. So what did I tell you? Knock knock. Cos x, okay, can we just go through and meet sine x? So definitely cos x will say, you have to get through me first, clear the first level. Alright, so we will do that by assuming that this is like theta. So we will concentrate only on cos x. So cos x will be what? Derivative of cos x is minus sine x. But what was our value of x? Our assumed value of x was sine x. So it's like sine theta. No, cos theta is equal to minus of sine theta, but we know that our x value was not x, it was what? Sine x. So that's going to be derivative of sine x. Oh yeah, so that's going to be sine of sine x, derivative of sine x is what? Cos x. I think that should be enough. Bus. Let's go to 3. What is our function 3 there? Okay, that's another simple question. Sine of ax plus b. Again, how many functions? To finally meet x, trigonometric functions there. After that only you have this ax plus b, where you are going to meet x face to face. So we have the first what? Knock knock, sine. So derivative of y with respect to x. Okay, it's always better to write the function outside. Don't write here. Okay, that is not advisable. Just write here. You can write here only when, let's say, the function is with respect to x. That's always advisable. But if it is not, then better not. Then again the same, almost a similar problem we had. We will assume this to be our sine, right? We will assume this value. We will assume this value to be our sine. I mean not sine, theta. So the differentiation of sine theta is what? Cos theta. Remember? But it is not theta. So that's going to be cos of theta by derivative of our assumed value of theta, ax plus b. So that's going to be cos of ax plus b. What is the derivative of this? Is going to be a constant. Derivative of x is 1. Okay, I'll just do this. 0. So that's going to be cos of ax plus b into a. Bas, that's our solution. Okay, what is our question number 4? 4. Okay, then we have finally we have an interesting question. Okay, finally we have an interesting question. Okay, let me drink some water. Okay, finally we have an interesting question. Now, could you identify how many functions we have here? Here, so far we were dealing with only two functions each. So now here, how many functions we have? We have here three functions. Sec of theta, tan of theta, root of x. Now before that, I'll give you one small trick. Not exactly a trick, but yeah, something like a shortcut. Not shortcut, but chalo, a quick way to remember certain things. Like for example, what I mean to say is derivative of x. There are some things which we cannot do again and again. We don't want to be doing those things again and again. Derivative of root of x, always like try to focus. It's proved also, you can check for yourself. No need to write so many steps. You can straight away write derivative of root x is 1 by 2 root of x. So it's these small things, if we can just keep it in our mind, then it can save us a lot of time also. Okay, it can save us a lot of time. So derivative of root x, straight away 1 by 2 root x. Let's not forget that. We will need that because I see root x here. So now here, how many gates do we have to cross to finally meet x? To finally meet x, we will be meeting under the roof of root of x. But to finally meet x, we have to first clear the gate of sec, then we have to clear the gate of tan. Then only we can go to root of x, where x is hiding. Okay, let's ask the permission and go to sec. So what is there? I'll just start with the differentiation. I don't want to write on the steps again and again. Okay. So derivative of what is the derivative of sec theta? Derivative of sec theta is kya tha? Derivative of sec theta was derivative of, okay, let me just write here. But you will have your copy there. You can, because I gave you the formula also, no? Derivative of sec theta was sec theta tan theta. So sec, what is theta here? Our assumed theta. Sec theta. Sometimes it can get confusing, okay, but let's not get confusing. Nah? Derivative of sec theta equal to sec theta into tan theta. Derivative of sec theta is equal to sec theta into tan theta. And then, of course, differentiate tan of root x. So here, remember, how many times are we going to proceed with the chain rule? We have three functions. So once, twice, thrice, two more. So that's going to be, okay, sec of tan root x, tan root x. Okay, derivative of now tan theta. What is derivative of tan theta? Sec square theta. That's going to be sec square theta. What is theta here? Root x. So the final one where we will finally meet our beloved, that is root over of x. So okay, I will not write. I'm a very lazy guy. Okay, so this will be same, this will be same, this will be same. Exams, please don't do like that. Okay, the teacher will get mad and then they will tell me, you are the one who told. So please don't do that. I'm a bit lazy. We have many problems to solve, so that's what I'm doing. So that's going to be what? 2 root of x. Just now as I told you, derivative of root x. Derivative of root x, straight away you can just write down 1 by 2 root of x. Okay? Alright. Mutual understanding between us, no? Okay, what is our next question again? Let's solve. Okay, so next question. Okay, let me do another question. Let's not do too many questions. Let's say, let me do 7. Not 7 exactly. Let's say that one is looking more interesting, like 6. We have here cos x cube into sine square x power 5. So like Bob, there's so many functions. Like let's separate them. Like this is 1, this is 1, again 1. So like this is like a product of two functions. See, it's all about identifying the functions. Okay, identifying it. So since we can see that it's a product of, again, how many functions, whatever be it, how many composite functions, let it be. So it's a product of two composite functions. So first things first, product rule. So first function into derivative of second function plus second function into derivative of first function. Similarly, the previous question, that is number 5, we can do by quotient rule. Okay, so I don't want to be extending the classes to like more than 1 hour and all. No, I think it's already. So now after that, let's see cos x cube. Now see this one, how many functions? So how many functions here we have here? Let's try to identify. Okay, let me just, are you done with this? So what I'll do now here is, okay na, same, okay, let me just write, otherwise some might get confused. So remember that only this is whole square, this 5 cannot be taken as whole squares, isn't it? We know that, we are already in class 12, right? Okay, sir, how many times are you going to tell us that, remind us that we are in class 12? Alright, I will not. Cos x cube. So how many functions for this one? Okay, so you can see that the problems are now becoming bigger and bigger. So like first, it's like x squared. Then only we can go to, first to go to x, we have to first clear the function of x squared, right? So we have to first clear the function of x squared. So what is the function of derivative of x squared? 2x, isn't it? Derivative of x squared is 2x. Then after that we have to clear the function of sine theta. Okay, no problem, we will write. So then the next gate comes sine theta, right? Then only we will have to differentiate x5 under whose umbrella x is existing, plus sine square x power 5. Okay, derivative of cos, this is quite simple now compared to the other questions. Cos x cube will be, derivative of cos x, if we just assume this as theta, so that's going to be minus sine theta, derivative of the other theta which we assumed, that is x cube. So that's like 2 cos x cube sine x power 5. Now same concept of this, derivative of sine theta is cos theta, then finally our assumed value, that is x power 5 minus sine square x power 5 sine x cube, derivative of x cube 3 x square. So then finally, okay, 2 cos x cube sine x power 5 cos x power 5, then we have 5 x power 4 minus 3 x square sine square x power 5 sine x cube. And then of course finally, if you want to write down the textbook answer, 10 x power 4 cos x cube sine x power 5 cos x power 5 minus 3x square sine square x power 5 sine x cube. So that is the solution. So this was actually a very good problem. Please revise this again and again and again. If you are able to solve this question, then definitely I'm sure you're not going to have any problems. Okay, you're not going to have any problems with any of the questions. Alright, so there are some more questions which I have skipped actually because it's becoming too lengthy, the video. So I don't want to be making it too lengthy. It's already too lengthy, of course. So there are some more questions, so we can try those questions. And what shall we do? One more, last, chalo, lagao, because that is also important against Some might think that, hey sir, this was a tough question, you skipped it. No? Alright, okay. Let's just solve this. That is 2. Yeah, yes, chalk. No, this. 2 root of cot x square 1 equal to. So I think this was question number 7, I guess. You can just check out. So derivative of y with respect to x will be 2. Now this again, to go to x, it is under the umbrella of x square. But x square is under the umbrella of cot x, and cot x is under the umbrella of root x. See, so simple, isn't it? So what we can do is, we have to first solve root over of x. I just told you what was the derivative of root over of x? 1 by 2 root x. So that's going to be 1 by 2 root of x. Now this part done. Now let's solve this. So derivative of cot x square. Let's not forget what we are assuming. Okay. 2 out. 1 by cot x square into. Now derivative of cot x square is minus cosec square x square into. Finally, we will reach the ultimate home, that is x square. Now actually I checked the textbook answer, so I will match with respect to the textbook answer and solve it for you. Now derivative of cot x square can be written as cos x square by sin x square, okay, into minus 1 by sin square x square into 2x. So minus 2x all divided by I'm just arranging. You can actually leave it in that previous step also, okay? But I happen to just check the textbook answer, so I am just arranging it with respect to the textbook answer, so that some of you may not think that you did wrong, no? So just for that. So see, one of the sign I am going to take inside the square root, so then it becomes what? So like cos x square sin x square, one ratio sign I'm going to take inside the root, so that becomes sin square x. So I'm going to just write here sin x square, okay? I think that's clear, isn't it? Because see, if you have x, root over of, let's say 1, so if you want to take it inside, then what will happen? Root over of x square, because from root over of x square only x is coming out, isn't it? So that's the same concept. So I'm not using both of them inside the root. I'm just taking one inside the root. That means one will be left out. मुझे छोड़ के क्यों गया ना? Okay. Why then? जाना तो पड़ेगा ना? So that's going to be minus 2x. So within the root, isn't it? So 1 sin x gone. So this is sin x square all divided by cos x square sin x square. So just to match with the textbook answer, I'm doing it according to that. So I'm multiplying and dividing by 2. So that's minus 2x divided by sin x square. If you remember this value, this is 2 sin theta cos theta, that is sin 2 theta divided by root over of 2. So our value is minus 2 root 2x divided by sin x square root over of sin 2x square. That's the textbook value. I hope so. I think yes. That's the textbook solution. You can check out. I think that's fine, right? That's the textbook solution. So yeah, sin square. All right. So friends, that's, I think you can just, of course, from here 2 root 2 just goes up. The denominator remains the same. So this is what chain rule is all about. So I hope that I could be of help to all of you. And then please, if you have watched the video till the end, please like the video. I need that for my encouragement. And please do share, and of course don't forget to subscribe if you have watched the videos. So next video we're going to do implicit functions. Yes, about implicit functions, or maybe we'll do more of chain rule again, because I think this is not enough, right? So I'll pick up some problems from different books, not from NCERT books, and we're going to practice more on chain rule. We need practice. Okay, so alright then, till then, bye bye, take care, hope to see you very soon.